நீ கேட்கலாம் வேண்டாம், அப்படியே போட்டு விடு. இது கட்டணும்.
Sir, we shall start, sir. If you are ready, you can start. Shall I, sir?
Yes, Krishna.
Yes, sir. Okay. So, dear participants, I welcome you for this session 5 on day 3. And we have Dr. R. Saravanan, Professor, Center for Water Resource, Anna University, Chennai. To introduce about the resource person, Dr. Saravanan, academic interest encompass surface water hydrology, groundwater management, watershed development, integration engineering, hydrological modeling, and climate change impacts on water resource. His work emphasizes the application of scientific and analytical tools to address real-world challenges related to water availability and resilience of water systems. He has actively contributed to research publications in reputed journals, conferences, and also involved in sponsored research project training programs. As a commitment of education, Dr. Saravanan has played a key role in curriculum development, mentoring students, and guiding research scholars. He has delivered expert lectures and participated in many faculty development programs, workshops, and technical training programs, continuing to academic excellence and professional development. His academic leadership and research contribution, Dr. R. Saravanan contributes to support sustainable development goals, practically in the areas of water security, environmental sustainability, and resilient infrastructure, and making the professional community very stronger. And today, he is to deliver a lecture on integrated water resource management in disaster-prone areas. Sir, on behalf of the organizing committee of ATAL FDP and also the Department of Civil Engineering of SRM Madurai College, I welcome you, sir. So, over to you, sir.
Thank you, but am I audible, Krishna?
Yes, sir, you are audible, sir.
My screen is visible?
Yes, sir. Now your PPT is visible, sir.
Okay. So I'm
yes, sir.
Slightly. Yeah, please tell me.
Yeah, your screen is visible, sir. Your PPT is also visible.
Right. Oh, okay. Very good evening, and to all the participants. Let me first thank the SRM Madurai campus for inviting me to deliver a lecture topic on AI related something they were asking, and they also gave me options for talking about IWRM and AI based. So now I included the both integrated component within the AI. So I revised the title as Artificial Intelligence and Emerging Technologies in Water Resource Engineering. My overview of presentation goes like this. First is introduction, then importance of water resource, then role of AI in water management. That means when you talk about integrated water management, then the recent technologies are very, very important for water management. So we cannot go away from the recent technology in managing the disaster or the management of any resources. So disaster means you have a both side of water resource, either the flood or drought. Both extremes, we call it as a hydrological extreme. Both the things need to be managed by advanced technique. Maybe the AI in the future will play a major role in managing the disaster of the hydrological extreme, namely water source, either surplus or deficit actually. Then AI applications related to some of the applications related to water source and how to mitigate the flood or how to mitigate the droughts. The AI will play a major role. Then the case studies, probably time permits I will take, or otherwise I just simply explain. Then the way forward. So before going to that, I am from Anna University, College of Engineering, Gindi, Chennai, which is 225 years more than old, which is the first college started by British people outside of Europe, which was started way back in 80s actually. So the center is the first autonomous center in College of Engineering, Gindi. It has a legacy of starting the course in 1956 related to water. Maybe we never thought about the importance of water, but still the stalwarts were thought about starting the course called water resource at the time itself. Then the first PhD degree was awarded the same center. Subsequently, it has been renamed as a hydrology water resource engineering, and we are also offering UNESCO courses and B agriculture water resource engineering, and we also introduced integrated water resource management as topic of your today's title. We are offering one PG program which is funded by Netherlands government, and totally we have totally so far graduated nearly 1,000 people, out of which only I am talking about really postgraduate actually. Nearly you can see the share of 43 male and 57 females. So far, the center from the center it is completed 1 PhD, and we have completed more than 500 number of consultants and research. So recently, Government of Tamil Nadu awarded to our center to carry out the water resource project for 3 years of nearly 3 crores with the support actually. The center also established by the father of hydrology student, Professor V.C. Kulandeswamy. Then the center had a professor. He did a PhD from Albert Einstein's son, and his name is Dr. Satyavedivel. He did from University of Berkeley. So so much of a legacy has the Center for Water Resource, and it's one of the pioneer center in the country. Then these are some of the laboratory facilities available in our center: hydraulics and veterinary library, DHE sponsor lab, and the computational capability of all water related courses. And we also have a field lab with all meteorological and smart farming, organic farming, everything we have. Now, coming back to the subject, why we are talking about integrated water resource management or the importance of AI in the present arena is that probably you are all aware the world population is keep on growing, but we also need to meet the water security as well as food security in the years to come. Now, if you see the trend, the population growth is basically due to the development and globalization and the medical advancement and so many things. Apart from that, the water sources keep on increasing not only by the population growth, also the type of utilization by the humankinds, like rapid urbanization, climate threats, and the living lifestyle, the luxury life, which demands more water. So, which pose threat to the water security at present as well as in future. So here, what I'm trying to say here is that you can see the graph. Let us take 10,000 years back. Almost the population almost flat till 4,000 BC. Then it started increasing. Now it is 10,000 billion is projected. Now we are currently 8 billion. So before 10,000 years back, we had only 44 million and 40 lakhs people across the world. But now we have reached to nearly 800 crores, 8 billion people across the globe. But we have the same water source. That means there is no increase in land, there is no increase of water, nothing is increasing. These resources are very constant right from the formation of the earth actually. Even the same land and same water is being enjoyed by only 40 lakhs people or 4 billion people 10,000 years back, need to be enjoyed by 800 crores people at right now with the same water availability. That means you can see the share of water which is shared from 40 lakhs people to 800 crores people. So here only your all advancement technology is coming in play a major role in managing the water, probably integrated water resource management. And to enable the integrated water resource management, ultimately you need the modern technologies. The modern technology nowadays, it is operated totally by the AI. So the limited resource need to be managed judicially, for which you have to depend on advanced technologies the advanced technology in turn will be monitored, or it will be operated, or it will be effectively utilized only by the AI-based the method actually. Now, though we have water in river or lakes, of late, maybe after 1980s, due to globalization, most of the water is being polluted. So, though the water is available, is unfit for drinking on any purpose. So the resource is not readily available for any use actually. The other side is, though we have water, we have a high intensity of rainfall. The high intensity of rainfall will leads to high droplet of size of water, and with a high kinetic energy, which will try to lead lot of soil erosion in the catchments, which will take more nutrient from the catchment to water body, which leads to turbidity, algae growth, and sedimentation and organic matters into the well. So in turn, the water quality will become unfit for drinking without any treatment. So the water quality will get, though it is water is available, water quality get affected by algae bloom because of carbon dioxide and methane and nitrous oxide. So these high intensities are rainfalls are due to the present phenomenon called as a climate change effect actually, which is due to the globalization in turn by the carbon dioxide emission or methane emission or hydrogen molecules. Now, if you see the urbanization, this is only for, I'm referring Chennai. This is urbanization long back, nearly 20 years back, right? So this is the 2000 year land use map. The same land is being changed by 2030. Will be the red indicates the built-up area. You can see how the red is indicated. Increased actually. So this increase is due to the globalization and people migration, and the settlement in a single place or in a confined area will pose a lot of threats to the water source in terms of availability and quality. And 50, this is I'm talking about Chennai. And the other important factor which affects the water security is, those days people have started living in the scattered or in the isolated manner, but due to urbanization, people have started settling in a restricted area or in a confined area as a group of population, which we call as a settlements or community, gated community or apartment type, whatever you call it as. So in a square meter area, a square kilometer area, 1980s back, the population density was very less. Now it is more within the 1 kilometer square, which leads to extraction of more groundwater from the ground, and that means the competition of the 1 square kilometer area by let us say 10 people 30 years back means now 3,000 people are extracting from the same 1 kilometer square actually. So the competition between the sharing the water source is one of the important, groundwater is one of the important problem. The real problem is, if the group of people are living in a confined region, and they started extracting the water from the same aquifer or from a confined region, then the water table level will keep on depleting actually very faster. This will lead to groundwater. This will lead to land subsidence. That means probably those who studied civil engineering, they'll be aware. The soil will be filled with soil volume, as well as the pore spaces will be filled with water volume. So when you extract the water from the pore spaces, automatically self-fate will leads to settlement. So that will lead to land subsidence. The classical example in 1980, way back, a groundwater depletion in Mexico City has led to 30 feet sink. You can see the photo. So the settlement is due to, if you keep on extract more water, then soil pore spaces will try to consolidate on its own. By the way, the land subsidence will take place. That means more extraction or over-utilization of groundwater also leads to a lot of disaster actually. In 2024, the same evidence was managed. It is observed across China. You can see that the environmentalists as well as the people, scientists were declared that most of the regions are under the land subsidence due to the water extraction and weight of the building actually. Now, this is the water cycle, probably may not have seen. This is recently a year back released by USGS, United States of Geological Survey. This is a hydrological water cycle, which includes all climate change impact components. And one beauty here is that generally for hydrological cycle to have a precipitation, normally the water need to condensate, evaporate from water bodies and transpirate from the trees, and it will form as a cloud. And you are all aware the 1/3 of Earth is on land and 2/3 will be on water. From the ocean, nearly 80% of water being evaporated actually, or 80% means the total evaporation in a year is obtained from only ocean. 20% only from the land, rivers, and lakes. But the nature gives a due share during rainfall. 80% of rainfall in a year will take place in the ocean. Only 20% will take place on the land. So that's how the hydrology cycle is balanced. And some of the statistics I would like to say: India's annual average rainfall is 1,236 mm, whereas Chennai is 1,200 mm. But Tamil Nadu is 960. But we are all far away, far beyond the drought cities called Israel, US, and some part of India. But still, we are facing water problem because of the lack of management. So Israel is pioneer in irrigation. US is, though it is 760, but still they are sufficient. So that means they are doing something else away. They are doing something new apart from what we are following, which is something but the automation or the advanced technology to manage it. The integrated waters management concept they are introduced to use it very judicially by engaging the recent technologies. So now these resources, as I said that, so these are led to a lot of water scarcity in the future to come. So to effective utilization of these water resources can be achieved only by the modern technologies. Now we are in the era of 21st century. Now AI is dominating the world and it is growing across sector. We heard about AI is used in healthcare, agriculture, energy. Now it is entered into water also. So you can manage the water very judicially, very effectively by introducing the AI related application actually. So the benefit is you can have handle the data, real-time data analysis, and you can also predict. For example, if this is your water level in a reservoir, and this is your daily demand, whether the water will be sufficient for 365 days or 90 days or 120 days, you can predict actually. Based on the evaporation rate, inflow and outflow, you can predict. So those things can be handled by AI techniques, which includes IoT, data collection, as well as the processing will be done by the ML applications. I will explain later actually. So the automation and optimization is the key for parameter which makes the AI more popular in the present year, in the recent years actually. Probably you are all aware AI I have heard about, and I would like to say introduce about maybe the new beginners. Though you might have heard about AI, I would like to say a few words about the AI. AI is nothing but it's a replica of a brain. It is artificial brain. How a human think, the same thing need to be processed by a machine, for which it needs some kind of knowledge actually. So that's what we call it as a modern days. It's called as a artificial intelligence. Intelligence, you are aware. Intelligence means it's related to brain process actually. Artificial means it is a man-made. So that means you are creating a machine which will mimic like a brain artificially. So that is called as a artificial intelligence. Like if you talk about people across the world, US people will think differently about a particular issue, and Europe people will think differently about a particular issue, and Asian people will think differently about a particular issue. That means though the brain is same, made up of same cells and other things, but the thinking capacity are keep on differing based on the exposure or knowledge gained. So this is what we call as a basic core of AI actually. So the AI refers to capability of the computer system. Here the computer system means it's a brain system to perform tasks that like typically requires a human intelligence. These tasks include learning, how we learn right from childhood to till date or every day, what is what and how to do it based on the previous experience. Then reason out whether it's apple or orange, reason it out, and the problem solving. If somebody is hitting you, how to protect, and if some problem is approaching you, how to solve it. Those things are, your brain will automatically do it because of the brain is being trained by so many years of observation. So that kind of trainings are required for the AI machine. If it is lacking with the lack of training, then the machine will think inferiorly when compared to human brain. But still, I'm telling, not all the processor cannot be replaced by AI. Still, the brain, our original brains, are far away from the AI processors. Then the perception and decision making. These are some of the behaviors or the properties of the AI. AI is not a single technology. That's what I would like to say, emphasize. So we people are thinking that AI will do something great and marvelous, but that is not the case actually. AI is only application, right? So it's a name, nomenclature given. But if you want to have the output based on this AI nomenclature, then it has to depend on some certain activities actually. Those activities are depend on IoT technology and the learning process called machine learning. So therefore, AI is not a single technology, but rather a broad field of encompassing the various techniques and approaches aimed to creating the intelligent machine actually. Right, now I would like to differentiate what is the AI and evolution algorithm, or probably we are talking about for 30 years optimization and the heuristic algorithm and so many things. So the optimization algorithms is a subset of AI, or it is a parameter used in AI to have a better decision making. That's all. So as such, EA or evolution algorithm cannot be compared with the AI. AI is a broad umbrella in which you have a lot of subset. The evolution algorithm is one of the subsets for optimization actually. We have two types of process only in a AI system. One is predictive, other one is simulating one, other one is optimizing one. When you talk about the problems related to optimization, then you have to follow certain procedure. When your problems are related to prediction, simulation, trials, then you have to follow certain kind of methods or algorithms. I'll explain later actually. So the EA evolution can be used as a tool within AI system for solving optimization problem. Probably this you can understand. So artificial intelligence is a broad umbrella term. Within that you have a natural language, computer vision, expert system, robotics, and automated reasoning, fuzzy logic, planning and scheduling, and flight scheduling and planning, and train scheduling, everything based on AI. Knowledge representation, speech recognition, AI ethics, cognitive computing. These are all some of the intelligence required for taking decision making. To take the decision making, first the machine should understand, for which the machine need to be trained. That means for training, we need some logics. So the machine learning, the machine will be learned. Machine need to be learned, or it will be learned by some of the algorithms actually, or some of the process, namely supervised or unsupervised, and reinforced learning, classification learning, or clustering learning, and so many the methods in which it will learn. So to enable the learning, you need some kind of the process, which is called network process, neural network process actually. Then once you have some idea, suppose if you want to have a deeper analysis, then you have to think deeper. Then the deep learning came into picture, which is a subset of neural network actually. Then the recent years we have generative AI, which is generated from the transformer architecture and transformer learning based on the knowledge obtained in a cloud or in a data set. Then it will be generated based on the previous experience and learning, but which is not a guaranteed one. The generative AI is in the process of development and not yet fully established and tested fully. The cognitive computing refers to, as I said, that cognitive computing refers to that computer system designed to simulate human thought process, enabling them to learn, reasoning out, and understanding the language in a manner to similar to the humans. For example, if somebody is coming from France and they're asking us to, they're telling that bonjour, our brain will not accept, will not process anything. It will think what he or he is telling, because we are not adapted to the language, or our brain is not exposed to the language. So that means the brain need to be trained in terms of known language. For example, somebody is translating the bonjour means it is a good morning, for example. Then our brain will absorb, oh, bonjour. Whenever the bonjour is coming to brain, we have to think that this is a good morning. So this is called as a learning process actually. So that is called cognitive computing, and so these kind of things are called as the learning process of any artificial intelligence. So likewise, across the world, 8 crore people's thoughts need to be trained within your machine. Then only it can you can expect a somewhat better result, which can be adopted across the world actually. Then computer vision, as I said, that is a comparison. For example, this is apple, orange. You have in a basket, you have a orange, apple, banana. Your brain will sense through your eye. So it will tell you that something is available in the bowl, and it will process within the brain process, and it will tell you that yes, there is a bowl, orange, banana, lemon, and peaches. It's available. But the same thing is replicated as this is actually human intelligence. Now this is artificial intelligence. You can come down. The eye is replaced by your CCTV cameras. Your brain is replaced with your CPU. Now the same input is available. The camera will sense and will go to your CPU, and it need to classify which is what, which is apple, which is orange, which is banana. The classification training will be done based on the previous experience and the data set which is available, fed into the computer system. If this is a color, this is a shape, and this need to be identified as a apple. If this is a color, this is length, this is width, then this need to be identified as a banana. So like that, it will process and it will give us a bowl, orange, banana. But you can see the output is same. But this is a natural intelligence, this is artificial intelligence. So now this intelligence, how it is learning, as I said, no, something is going on inside. The inside process is nothing but the learning process. The learning is called as a machine learning. So machine learning is a subset of artificial intelligence that focus on the enabling the system to learn from the data and improve their performance over time without explicit program actually. Essentially, it allows computer to analyze data, identify the patterns. As I said, no, it's a circular or cylinder, whatever may be patterns, and make prediction and decision based on what they have learned, what the system is learned. Right. So then this learning process can be done by neural network algorithm. Probably neural network is original, how the brain will behave, neurons. But we have ANN. ANN means artificial neural network. I will tell you later actually. Neural networks are the computational models inspired by the biological neural networks in the human brain. They are type of machine learning algorithms used to data analysis, recognize patterns, and make decisions actually. The deep learning is a subset of a neural network. Suppose if you want to analyze in depth about apple, then we have to use a deep learning. Or if you want to analyze in depth about any concrete, any object, then normally the deep learning will be used actually. Now I will just look at this picture. This is our actually from biology book. You can find this anywhere. This is the cell body, our neuron, right? So this will have a nucleus and cell body, dendrites it will have. Then you have axon. So then you have a synapses actually, right? So this is actually the neural network of our human. But this has been replaced mathematically. Here you can see here. So the dendrites, the nucleus on cell body will transfer the information to dendrites. So from dendrites, it will go to the axon. From axon, it go to synapses actually. This is the process will take place. That means this is your nerve system, or where you touch here, then it will transfer the feelings to the brain. So likewise, it has been replaced. The input signals x1, x2, x2 are these are all the dendrites, nucleus, and cell body. Action will be done by the input layer in neural network. Then weights and summation is nothing but from all the dendrites or from all the inputs, so it will synthesize and will take it to the brain. For example, some heat is you are going nearby the heat. Throughout your body will sense the heat. From all the nerve system will transmit the heat information to the brain. So that means the brain is receiving from several neurons. throughout the body, neurons are telling to brain that there is a heat. So like that, you have several inputs from the inputs will be collected, will be summed up, and each one will be given some weightage. For example, the feeling, if you touch it, unless you touch it, your finger will not feel the temperature. So that means that in those cases, we'll have to give the less weightage. Whereas the skin or eye will straight away will affect by temperature, even in small increase actually. So that will have more weightage. So like this only the AI, so ANN, they'll use the weightages in the hidden layer, and to activate the hidden layer will be available. How to activate? We have a lot of functions called nonlinear activation functions, and we also have linear activation functions, and finally you'll get output actually. For example, you can ask me what is a function of activation function. You can take it straight away. For example, there are two humans are available. One human says are brain dead actually. Brain dead. Other one is a normal human being. Though both the bodies are, it is a living body. Both have a life actually. But if you pour some heat, if you pour some hot water, if you pour anything on the dead brain body, it will not react. That means there is no activation function. So the neurons are not transmitting that there is a heat is coming or touching your body. So that means unless otherwise there is activation function, you cannot ensure that the body is a live body. Otherwise, though the body is live, but it is solving the purpose. So that's what the biological process has transformed to AI. That's right. So I won't explain, but here the functions are threshold logic function, sigmoidal function, those so many functions. Basically, we have a supervised learning and unsupervised learning, and reinforced learning and semi-supervised learning. These learnings are available, and we also have the feed forward and the back propagation algorithms also we have. So in the deep learning, you can see here. So normally ANN we call it shallow layer, which may be input layer, hidden layer, and output layer. Whereas deep learning will have n number of hidden layers, which will try to learn in depth. Then it will take the output. These are some of the deep learning techniques they can understand very easily by looking at that. So the LSTM has recently used MLP, multi-language processing, convolutional neural network, RNN. Probably people are using now LSTM. LSTM are widely used methods. Now, generative AI. So you can see the right side, the real is actual image, but the generative AI image is left side. So most of the video you are seeing as a AI video is a base, is some image. From that, it will take and it will transmit the process and patterns, and it will generate the AI. So likewise, for example, you are capturing any image, let us say building image or road image, any image from a domain, and segment it and feed all the data information to the computer. Whenever you capture image similar to that, then that will realize that it is a road, it is a building, and so on. So that's what actually generative AI does it actually. Then major ML categorization of water engineering management. You can see here we have supervised learning, unsupervised learning, and reinforced learning. Reinforced learning. And the supervised learnings are widely used for labeled data set. That means if any information, known information, then supervised learning can be used. For example, you can use a linear regression and logical regression, support vector mechanism, kernel function, recurrence neural network, and random forest, and so many things. So he used for basically classification and nowcasting problems. You can use the supervised learning. For unsupervised learning, generally used for clustering problem. For example, you have 100 water samples and you want to cluster it. Which are the samples are nitrate is more. You can cluster, well clustering. What are the data set you can want to cluster? You can use a unsupervised learning with the k-mean cluster, hierarchical clustering, and so many Gaussian. Reinforced learning is it is in the process of development, and without any predefined data. But for all these things, you need a data without any predefined data. Then based on each child, it will learn on its own and it will take a decision making. So like Q learning, WQN, these are all some other things. Now IoT applications and IoT ML AI. So as I said that AI is a broad AI in which you have IoT and ML, so many things. Now for forecasting problem, let us say flood, drought, or demand or water level, you want to sense the water level in a river system or in any place for which IoT is required. Then for training you need ML is required. For decision making you need a AI is required. So what are the field you talk about? Either forecasting problem, smart irrigation, prediction, water quality problem, and policy support or scenario modeling. Wherever we talk about, everywhere all the three are plays a vital role. The real-time data analysis, now coming back to the water source and AI applications and applications. And you can see here the left side is the water flowing. This has a flow as well as water quality. So the sensor is installed. It is a sensor. This will capture the water level and water quality. The sensor will be transmitted through server or cable. So this sensor will capture the image. So this process is called as IoT, Internet of Things. This information will be transmitted to a cloud of the cloud. So from cloud, they will fetch the data and they will process and they will take it. So the IoT is here, and the transformation is going as a data set, and it will be processed by machine learning, and then conclusion, whether how much water is flowing, how much you have to treat it. So many things will be taken decision by the AI process. And you can see here, sometimes the water is very high, then very low, very low. So at what you want to withdraw the water from the river, and you can see that actually. So daily, wet season, annual season, and so on. River flow, you can. Then real-time data analysis has said that. So from everywhere, the data will be collected. It will be stored from sensors, and it will go to cloud. From cloud, it will come to the your dashboard or your CPU. Then you can make the data need to be processed through machine learning, and what kind of information will get it. Then you have to take a decision based on the AI. Then it's a predictive analysis. You can see here water supply here. Let us say you can see here the water is flowing from buildings, and it is coming to the river system and water supply network, and you can predict which network has the more water supply, which has the least water supply, and where is a possible burst or leakage will take place. So many things you can understand, and water accountability also can be made very easy. Water accountability also made very easy. These are the main components of networking monitoring. Sensors will take it, will estimate the data, will be fed into the cloud, and you have GIS platform backside, and it will process and it will tell you that which area is prone for flooding, bursting, and so many things. So flooding as well as leak detection can be done by hydraulic model. Even if you want to model, your IoT and MLs is required, and to have a better output. Then river water quality problem, as I said, that either you can also sense it from static sensors, as well as you can also deploy the sensors in a moving or like your drones. You can fit it. The drone you can allow it to fly, and it will take the water quality across the water body. Then it will transmit. Then you will get a time series of water quality data. Then you can cluster it. Which other portions are highly polluted? Then you can take a predict and what will happen in the future. The same kind of pollution trend is going on. Then what will happen in the future that can be predicted. So here IoT is here. Then it will go to time series. Time series will be analyzed based on the machine learning algorithm. Then what kind of treatment is need to be taken will be done by the AI process. Then the flood and drought, as I said that. Flood forecasting. It will collect the data from rainfall, all the things from the data. You can see here. Then in rainfall and land use pattern, will take it and you will be feeding into the computer. Then computer will process, and which area likely will get flooded. It can be simulated actually. So it's called real-time flood forecasting actually. So data will be captured by sensors, which is called IoT. Then sensors will be transmitting the data into the cloud. From the cloud, the data will be downloaded to the CPU. From the CPU, the process will take place based on machine learning. Then the learned output will be superimposed with the your Google Map or Google Earth, and to have a better flood prediction zones actually. And when you come to drought, let us say you have one area, and one area is keep on you are extracting more. Then maybe after some time, this area will undergo for drought. So then you can say that your AI will predict. So if you keep on extract more water within a year or within 10 years, the area will become desert actually. So you can see here the real IoT AI-based drought planning system across the US has been modeled, and it has been given as a geospatial scale. Right, you can see here. Then extreme climate prediction. So the climate also can be predicted very accurately. Nowcasting, you can see here, based on the continuous monitoring of the satellite in a particular region, it will capture a lot of images. It will process by a supercomputer, and it will gives you how the cloud is moving. So maybe probably you are aware, you have seen that weather prediction, weather forecast during monsoon season. So they are using random forest classification, neural network training, Bayesian interference, all other methods they will use it, and for monthly time, weekly prediction, monthly prediction, or yearly prediction, or decadal prediction. And random forest actually, right? How it will classify? Which will initially it will absorb visual feature, physical traits. For example, you have a instant. For example, you have 3 basket of fruits. One from one basket, the model is trained, and it is saying that it's based on apple's shape. Let us say shape based on apple shape. It is telling it is apple. Based on color, the second trial it will gives you apple. Based on third trial, it will giving us a banana. But out of how many trials, the major trials will be taken, and what will be done. Finally, it will be classified as a apple. So this is how your AIs are working actually, right? So we will think that something is coming as a visual, but there are several processes going into the machine. So same way, it can be used for role of AI for precision farming, smart farming, sensors from crop, it will be taken and it will be sent to software, data will be transferred to AI, decision making, then actuate the walls, which exactly location requires of water and fertigations, that will be done by AI methodology. Maybe next slide will indicate. You can see here, based on remote sensing, so based on the sensors captured, the data, and which trees or which plant requires water, that can be exactly sprinkled rather than supplying water throughout the field actually. So the site-specific applications are feasible only if you have this kind of data set. Then the leak detection. Leak detection also can be done by monitoring of the AI. Maybe I can tell you, I show that this is your conventional, traditional method of checking the leak. They will take the chart, they will measure each wall's location. But now we have geophones, microphones, and simply send it. AI-based leak detections are available. And which location is, you can see here, this is the location. You can send it and you can send it. I have several examples. The lot of logics are supported is involved. If you place a sensor here and here, then there will be a noise variation between two sensors, means something is happening inside. So through that, the leak detection will be taken. For example, the pressure is more. If the pressure is very less, then between two sensors, the pressure is decreasing very rapidly. That means something is going on, maybe illegal tapping, or maybe the leakage is taking place. That can be sensed and it can be monitored. Leak detection can be estimated. Then we also have a hydrophones. You can send it to the well or water supply pipeline system, and wherever the internal bursts are taking place, there will be a noise will be different. So with that noise, then you can plot the graph for the noise value of water which is flowing without any seepage or without any leak will have a different pattern, and with the leakage will have a different pattern. So based on that, they will identify at what location the seepages or the leakage taking place. So as I said that, so it will sense between two sensors and it will emphasize it. And we also have a fiber optics. The fiber optics is very accurate, and even it can sense the leak of, let us say, 200 ml also will be sensed. So which is basically AI-based optic sensors that will be sent into the pipeline and it can be detected. So pressure flow based on the flow sensors between two places, and the sudden decline in pressure will indicate there is the drop. And we also have a GPR, ground penetrating radar, with the AI that will sense the subsurface information and you can see the two graphs. So one is signals, and you can see here there's something obstruction is here, so which means that there is a pipeline is going downward, and even water table level can be estimated for shallow depth. So the ground penetrating radar will be widely used for different soil moisture and things like that. Maybe the next it will indicate thermal imaging. So here when you just scan the subsurface or earth, actually you'll have the reflected value like this, and the red zones are called as a leak zones, where their leakage is taking place actually, and the blue and green zones are the less leak zones, or there most almost there is no leakage at that place. So based on thermal image, you can use water leak detection. Then leak detection can be by advanced sensors. You can see here the signal supposed to transmit. If any leaks takes place, then the leak noise and wave will be propagated to the hydrophones. Then it will have a different. Then you have a the pipe with the leak filter, and it will have alarm. You can take it actually. So how it will look like comprehensively, and the red zones are the high pressure zone. Each and every place in junction nodes they will have a sensors. So sensors are connected to monitor. Every time period, every seconds it process, it will tell you that pressure, velocity, water quality, everything. Now these red zones are very high risk for pressure as prone for the busting or leaks actually. So the wave operation within the pipeline, you can see here. So this is the wave operation. Normally it will be like this. When the pump is operated, you can see that there is a spike. Then pipe burst means there will be signals like this. So during construction works, the vibration will be totally different. It is spatial vibration will take place. If it is any external events will take place. These are some of the algorithms are used for leak detection, and you can just from PPT you can check it. And now using this IoT based technology in Barcelona, Singapore, Cape Town, Africa, US, Atlanta, and Melbourne, and most of the places they reduced water losses by 25 to 15 to 30%. So, but as of now, we are facing 40% loss, but achieving less than 10% is international standard. To achieve that, you require a dedicated monitoring system, which is only feasible by IoT based and AI based the technology actually plays a major role. So we have implemented SCADA by IoT based long back in Tirunelveli Corporation for a corporation water supply and the supervisory control data acquisition system for nearly 5.2 lakhs people to supply water. And we are installed as SCADA, and as you can see here, this is the SCADAs are installed here, SCADAs, and you can see this is a program logical unit is installed. The data will be collected, sent to the PCU, and it again goes to the cloud. The actuator, this is a PLC unit, and the flow sensors and pressure sensors are installed, and the sensors where data will be transmitted to the cloud, and right, the valve also will be operated automatically based on the demand. This actuators you can see without any human intervention, it can be rotated, and they did it, and ultimately everything will come to the dashboard, and which pipe, which water tank, which pumping well, pumping how much, what is the water level in the water table in the water tank, and what is the flow, and which region is not receiving water. Everything can be monitored in a single dashboard. So one can take a decision and immediately. So rather than wasting and going to field, one can take a decision from this. So how it works, you can see here. This is the SCADA dashboard, IoT enabled dashboard. You can see each location, the values are changing. The pressure, walls, tanks, everything will change. Then based on this, you can take a decision and which locations are really under threat. So the AI-based water quality sensors, probably I want to tell you means, for example, pH sensors, we have a turbidity sensor, EC sensor for each parameters, you have different sensors. Then that will be connected to the Arduino board. From Arduino board, data will be transmitted to cloud. From cloud, you have to download into machine learning, process it, and get the data. That's all. This is what the IoT ML AI. Now, water quality. Probably the school students also will do. They'll put some sensors into the water glass of tumbler. Then they'll say that it is a pH is so much. These are IoT enabled AI instruments, small level instruments. Then you can also use it for scenario building, like a leak management, flow monitoring, and overuse contamination, and so many things actually. Now, how much time I have?
Sir, you can continue, sir, till 7:30. You can continue, sir.
No, but I will take some time, not 7:30, but
Okay.
finish it.
Okay, sir, no problem. Sir.
Right. Okay. The plus of the actual schedule is up to 7:30 or 7.
7:30, sir.
Oh,
If you want, you can continue up to 7:30, sir.
Right. Okay. Then no issue. Right.
Okay, sir.
So the pillar of AI frameworks, if you see here, we have the left side of domain pillar, which is called data, readiness, knowledge, information. This is one part of AI, and model development, how to fit it all the data into a particular fashion, which is called the model domain or middle domain pillar. And right domain is nothing but the decision taking. So collection, processing, and decision taking. These are the three pillars of AI. So probably you are aware, Israel and Singapore. This is one of some of the successful case study. I want to. Israel is one of the lowest rainfall country, which collect almost 500 millimeter per day, which is far less than the Indian average. But they are pioneer in irrigation. So what they are doing means they are including introduce a integrated water concept. They will collect rainwater. They will collect a sewage water from their own country as well as from nearby country. Then they will treat it. They will with a stringent water quality monitoring. Right? They will treat it, and now then ultimately they are getting as an output as a potable standard. Actually, potable standard water quality they are getting, and they are using for irrigation, drinking, everything based on the integrated water source concept actually. So if anybody travel to Israel, Singapore, and definitely whatever water you drink daily in basis, it is combination of both the treated water as well as the fresh water. So, but sometimes scientists have proved that these waters are much more better than your rainwater actually. So much of ultra filtration has been done, and it has been proved. In fact, Singapore is a public utility board. They have implemented AI-based water supply system, which is called as a public utility board. New water system, new water actually. So new water means it has a new birth from the wastewater actually. They never call it as a treated wastewater. Instead, they will say it new water. So that means they from bad water it had a new birth. Therefore, it is called as a new water. But these waters are undergoing 130,000 test, which is far beyond any standard. So you can just close your eye, you can drink it actually, right? So those kind of things are possible only by the advanced technology like IoT AI. There are success stories available in Israel and in front of our eyes, Israel as well as the Singapore. So the Israel, as I said, that is a right. Israel technology is the pioneer technology. At a particular place, if you want to drop it, they can drop it actually. So this is a precision farming and AI powered. AI will tell you that which region is soil deficient, moisture deficient region. Only they will open that valve. They will get actually. This is what I was talking about. Public Utility Board, Singapore. Singapore smart water system. You can see here there's a rainwater is coming. There is a sea because it's island sea. From all the regions, they will collect the storm water and collect it in the rainfall, and they will take it to treatment plant. For treatment plant, they will take it the treated wastewater, seawater, treated wastewater, and fresh water. Everything into the tank, right? Everything tank. Then they will treat it. They will use it to industrials and households. This is what the AI smart water grid using AI as a Singapore actually. Then application of ML to spatial temporal studies in water source. If somebody want to use hydrologic experiment like flood and drought, they can use LSTM methods and flood convolution LSTM and flood RN, NNN and RF and drought you can use. So these are some of the field-based algorithms one can use it, which are already well established literature available. They can use it. So likewise, water monitoring, sedimentation, hydrology. So you talk about any research, any field of research in water source, and you can find one algorithm, right? So the AI is not not owned by only by computer people domain. It is also can be widely used for real world problems like water source as well as civil engineers, electrical engineers, mechanical engineers. Everybody can use it, because only thing is you should know and you should understand how to convert the physical property into the mathematical property or mathematical language actually, or mathematical process actually. That's where the one's strength is required. So you can see stream flow everywhere. You can have a flow actually. Now ANN, CNN, RNN. ANN is the first one, artificial neural network. CNN is a convolutional neural network, and we also have a recurrent neural network actually. ANN is renamed after NNN. Neural network is original. Then it is called as artificial brain. Therefore, it's named as artificial neural network. Then within that, convolutional networks are available. Then we also have a recurrent neural networks. The three primary architectures of the deep learning. So these three are the one way or other way it is inbuilt with your deep learning. Your ANN are generally general purpose. Fully connected networks are for future data sets, structured data sets. But CNNs are optimized for a grid-like data, image and videos kind of information. If you have to use a convolutional neural network to process it better. And if you have a text or like let us say natural language processing, NLP, right? And text as well as time series data, if you have, then RNN is a recommended algorithms are. So ANN, CNN, RNN, each one will be suitable for a particular kind of data set actually. So if it is a image, you have to go with the CNN. If it is text, time series, go with the RNN. So the primary architecture, core architecture of the application of difference if you see here. ANN basically used for pattern recognition, financial forecasting, any forecasting. Convolutional neural network, image classification, object detection, medical image analysis, and autonomous driving, automatic driving car, driverless cars. Then recurrent neural networks are widely used for natural language processing and speech recognition. For example, if you talk in Hindi and translate in Tamil, Malayalam, and so many. If somebody will talk if somebody goes to China, then if you speak it, it will convert to Chinese language, which is called as a machine translation. And based on individual application, one can use this kind of things. So this is ANN and this LSTM, LSTM. ANN is a simple input and output, but DNN is a deep neural network, will have a more number of hidden layers and will have output. But convolutional network will have a feature extraction at the middle, and CNN based on the input and feature extracted, it will be trained to the model in ANN. Then you will get the output actually. You get the output, which is called as a convolution CNN. Within the CNN, you also have the LSTM. LSTM will have. Now, I would like to, because the recent days people are talking about CNN, deep learning, CNN, LSTM. So this CNN, LSTM, deep learning can also be used in any field, provided if you understand the concept. So here we have a feature maps and feature extraction. Probably they'll talk like that only. A typical convolutional network will like this. It's called kernel. Then which is called input image. Kernel means it is nothing but input image, input value. Then feature maps, pooled features. Then the feature maps, pooled feature maps, and flatten the layer. Then you will get a neural network and you will get output. I will go one by one, you can understand very easily. So this process, that means from input to the feature map, converting is called as a convolution. From the information available in the image and pulling out and taking back to the pooling process. Then convolution is the again within the pooling process and converting row to column, column to row. Then that is called as flattening. So this is the process will take place. I will explain. So recurrent neural network, as I said, that the hidden layer will be available. The output will be sent back to the hidden layer, process it back, and will come back. Then deciding ANN architecture. How to decide architecture? The input layers are nothing but number of neurons. Output based on the. I don't take much on time on this. And you have activation function. This is a binary function, linear function, ReLU function, and we also have a tan function, sigmoidal function. So each function based on the problem specific thing you can address as an activation function. Right? So activation function. Then summary, if you see here, the ANN is the most basic form of neural network, consisting of input, hidden, and output layers with a fully connected neurons. Whereas, as I already said, that is for the spatial information upon flattening. This is for the edge and shapes convolutional network, and the RNN will be used widely used for capture the temporal dependency on the contextual and the sequence data. So standard RNN can be challenging. LSTM and NPL, as all these things already said. Okay, now coming back to LSTM. LSTM is the long short-term memory, which is a part of your deep learning, which will have, right, LSTM which will have 3 gates, right, or I'll come back straight away to the LSTM, right, which will have a LSTM try to add a long memory, whereas RNN, it will not have any memory during the process, whereas in the case of LSTM, it will store the memory for short time and it will process with the memory. Whereas RNN, it will not hold any memory, it will not store any memory. Each time it will learn freshly. That is a basic drawback between, or basic difference between RNN and as well as LSTM. So here you have the they have 2 inputs instead of 1 input, and their comparison. Okay, LSTM chain you have here. LSTM architecture will be typically like this. We'll have 3 gates. One is a forget gate, input gate, and output gate. Here you can see forget gate is here, and the input gate is here, and output gate is here. So the input will take the value, process it, and what are the information necessary will keep it. Other necessary information will be forget on its own. Then the remaining will be taken to the output actually. The cell state is nothing but where the information coming to all together from sigmoidal function and tan function and all the functions, it will transmit the information to the cell gate actually. And you can see here this image. Inputs are going and it is processed into 2 input TAN gate and goes to cell further, and forget function will take place. Then it will go to the TAN H. Then something will go forget gate, and you will get output at the final H. This is a process. The TAN active function sequence swashing the function, while sigmoidal activate as a decision function gate actually. So the TAN H, you have TAN H function. A tan H function you have, so that will tan H function is somewhere here. This will discard. Squash the unnecessary informations and preserve only the sigmoid would only preserve the gate function. First, let us see. The input is going as a CT plus 1. Then input is going from here. This is CT minus 1 and comes as a CT. Then here is a HT plus 1 and HT is going to function and reaches to this place. And the FT is nothing but the information obtained from these two is called as a summation of the function, sigmoidal function, WF into HT minus HT comma XT, as well as BF. BF means is the weightage which is the bias which is taken from the process. Then it will go to second tan function. So like that, it will process into tan H. It go to again back to the cell state. Then go to tan H function. Then it'll forget and it'll take the value. So the process will be taken like this, but it takes us a long time to explain with the thing. So the machine learning, I'll come back. This is already we have seen. Now, what are the layers in CNN? Input layer, convolution layer, activation layer, which is called as a ReLU, and pooling layer is a simulation layer, drop out layer called optimal layer, and the batch normalized layer is called optimal layer, flattened layer, and a fully connected layer is called a dense layer, output layer. And CNN can be used for edge detection, feature, and object. Okay, I'll straight away go to the small filters and things like that. Now, as I said, you have the image is obtained here. The image cannot be straight away processed using a neural network, because neural network requires a data. To have a data set, image cannot process by the neural network. So from each pixel, the values are converted as an input layer. How the image is converted as a single values or input layers values rather than as image, the image will be converted into neural or into values actually, either one binary values, 1 or 0 or something like that. So to convert the image into the values, all the processor will be taking place, like convolution, pooling, and so many things actually. So the kernel means it's basically called as a filter. Kernel means basically called as a filter, right? That we have small filter means here the filter means 2 by 2 matrix, like that we'll tell you. So 3 by 3, 4 by 4, 7 by 7, and so on. Even 1 by 1 also can be taken. So in summary, filters in CNN are dynamically trained to become a specialized feature detectors with their primary classification based on the size of the kernel used in the convolution neural network. Now, convolution. Let us say you have image with the input image is like this, but it has information. But information, let us say 9 represents the road, 4 represents the building, 1 represents the river, something like that. But the computer cannot read the river, building, road as such actually. Instead, they will be renamed in the form of values actually. So those values now we are going to convolute actually. So the entire image will be transformed into binary or machine term, nothing but 0 and 1s and values actually. So if you have like this, then the filter will be kernel filter will be used 3 by 3, 3 by 3, let us say. Then they will take output array 3 by 3, they will take it 0, 2, 1, 4, 1, 0, 1, 0, 0. So they will take all these 3, and you can see how it is being estimated actually. You can see here. This is the kernel value, the activation function value. Then here is the value you can see here, 9 into 0, 9 into 0. If it's a 2 by 2, then only 9 into 0, 4 into 2, then 1 into 4, then 1 into 1. That's all. That is a 2 by 2 filter. Here is 3 by 3 filter. Then they make it and they get it as a 1 value. So now the entire 3 by 3, 9 cell values are converted into single cell value. So likewise, if you move these 3, then you'll have a second value. Then this 3, you'll have a third value. This process is called as a convolution process, right? Convolution process actually. You can see here. Then you also have a strides. Strides means single stride, 2 strides, and 3 strides. So many things you have. For example, you take stride is 1. Let us say you take 3 by 3. Each 1 by 1 layer you have to change it, and you have to get it actually strides. Suppose you change 2 by 2. You take 3 and change to 2 by 2. You leave two columns. Then you take the next 3. Then it is called as a 2 strides actually. You can see the 2 strides. This is a single stride. Each layer will be shifted, but here you can see 2 strides. Everything will be changing 2 by 2. So like that, if you do it, then you will have an image like this, for example. Right? So convolution. Now padding. Padding means you'll get a values like this. White matrix is the actual value you got it. But on surroundings like a buffer, you are giving zeros to all values, so it will not have any impact. So that means if you don't want to lose information of this value, then you have to take 2 by 2 like this. If you take 2 by 2 like this, then you will be losing the importance of information in this location. Therefore, normally they use a padding. Padding means to take care of the maximum weightage or utilization of the individual cells. So in this case, they'll use zeros at all the corners. Then these 4 will be taken. Then it will have a 1 value. Then they'll put it. So this is also zero padding. If you don't want zero padding, also is fine. You can do without zero padding also. This is activation layer, relay layer. So the activation layer will forget. Let us say I was talking right, dead brain and active brain. So all the plus will be taken as a 1. That is a real value. The minus are not interested, therefore it put as 0. So this is a relay function, activation function. So the information what is obtained from image, useful information will be taken. The non-useful information will be left out by forget gate. So that is a relay. You can see the function is here. Then pooling layer. So the pooling layer 2 by 2 is available. So the pooling layer is nothing but you can take these 4 values and you can bring it as a 1. And these 2 and these 2, this red actually, right? This is the 100 maximum pooling means out of 4 values, which is maximum 100. Out of 4 value, maximum 8. So like that you can pool. You can bring it to single values of maximum pooling. Average pooling means you add all the 4. Divided by 4, then you'll get a 36. 100 plus 15 plus 31 divided by 4. If you put it, that 36 will come. So this is average pooling layer. So like this, the batch normalization, you can see this ARN network is here. Then flattening. Once you get the values like this you have a number of pooled maps. You will have pooled information. This will be the rows and columns will be flattened into only verticals or only the columns. Like 6 will be here, 8 will be here, 4 will be here. So now this can be read by your ANN model because ANN requires the input. So now the entire image is converted into input form. Now you can refer back to your AI process. You can see here, if you want to have the information about image, you have to do all this process. Right now, I will tell you in simulation application, if you take a building image and if you have moisture is curing is taking place properly or not, take the image and process it, and which portion of wall is less moisture content is available, those things can be transferred from this layer to input layer. So that's what actually converting from image to the values, and the values will be feeding into the ANN input layer actually. This is a single flattening, but we have a 3 or 4 pooled feature layers available. So each one will be here 1 3 1 3 1 1 is the based on blue, then 0 2 0 1 is the based on the purple, then 1 1 2 0 is based on it. So you have a number of layers you can have it, but everything will be transformed into the single input layer, so which is called as a flattening. Once you flatten it, then the ANN will take care. So as I said that ANN cannot read the image as such, but we need some conversion process. That's what your CRN will does it actually. So that's what we have discussed. So fully connected layers, each layer. Then once you give it, you give an individual weightage and you will get the output layers actually, right? So output layers. So this has been applied dropout layers. So basically, I will explain with only one simple example. Input, all the things. We have highlights, for example, here they use the time series data of a cloud. Then they did all the pooling, convolution, 2 by 2 and 3 by 3 and 2 by 2, then flattened vector. Then they given an input to the ANN. They also use the LSTM method. Then finally they got the output. So you can see here input matrix, filter scan, CNN convolution process, flattening, configuration and fully connected layers, and LSM cell process and fully connected. Finally, you're getting the output. So the output will be is getting like, so this is the how the process will take place, as I said. So one by one, orange will move from one place to one place. Whenever it's going, one cell will be, it's a convolution. This is the minimum maximum pooling. Already I explained how the minimum maximum pooling will be taken. This is the flattening condition. As I said that from here, it will be flattened, I will be getting it. Then this is the fully connected layer. Then LSTM will be used to give the input to the layer. Then they are getting the output. The model predictions are estimated in flow in the river. They got it. And based on the flow forecast, the flow in the system based on CN and LSTM. And for 10 days, how the prediction based on rainfall, it will predict everything is given. And the model has been calibrated based on the R square, NSE, and RE. So though we have, but only thing is we have equipments and technologies and machines are available, but the data acquisition and the dedication, data collection, precisions plays a major role in getting the reasonable and reliable output using AI models. So I think so with this, I'll stop it here. If you have any doubt, thank you. You can ask me.
Participants, if you have any doubt, you can ask now. You can place your doubts in the chat box also.
Good evening, Professor.
Yeah, good evening, Dr. Gauri.
When we are working with AI and ML, with respect to the water resources studies, we are lacking in the real-time data. So how do we compensate for that real-time data?
But the thing is, yes, you can. That's what I said. You can use IoT. You deploy sensors, either static or floating sensors, or mobile sensors using drones. You just fix it in a particular place. It will communicate every minute by minute water level or water quality in a system or in a tank or lake or in a pipeline. It will transmit, and you can monitor from the here, and you can take a decision. But data acquisition is for AI is widely recommended using IoT method. Deploying sensors, continuous monitoring of data, only feasible not by manual, only by the automated, nothing but sensors actually. So if that is the case, you can use it for any purpose. For example, river flow, and irrigation supply, and dam release, and rainfall during monsoon rainfall pattern, even wind, how much wind is blowing, wind, water noise, then how much settlement is taking place in a building. Everything you can place as sensors, then continuously it will monitor, like how your earthquakes machines are working, Richter scale, right? So those scales, so it is continuously monitoring the earth movement or vibration. So likewise, you have to deploy any sensors, dedicated sensor for your field of application, and it will collect every minute by minute. It will collect the data, and you will have big database. And I would like to say, when your data are very limited, AI, ML not at all recommended.
Yes, sir.
Simple regression, analytical method is sufficient. Analytical method is sufficient, right? So for big data only, your AI, ML will work very perfectly or very robustly. So having only 10 data, and I want to use AI, ML, then it's not I would say it is meaningless. It can be solved by manually, right? You have spatial variation, temporal variation, and continuous monitoring of data. If you have, then yes, big data, it is recommended to go with the AI with ML based applications.
But when we need to do any study related to the back data, like the previous years, and then predict for the future years. How do we compensate those data?
Yes. Suppose you have, let us say, you have a data from 1990 to 2000. You have a data, but 2002, 2010, sorry, 2000, 2002, 2 years you don't have data. Then after that you have data. But you can take these the past data and present data. You can train them, and you can use a data mining technique. That is called as a data mining technique. And nearby for example, if you have a water level in four corners of the well, one well has a 10 meter, the other one well has a 11 meter, the other one will has a 12 meter, the other one will has a 13 meter. What will be water level in between?
We can have a weighted average for.
That's all. Which is called as that's a data mining. You are using the four data. You are mine the you want to mine the data which is there. Data is not available. There is a lot of software available. Data mining. Missing data can be filled with the capturing of based on the previous and past data. Train them and take. This is a likely data where you are missing and where you need actually. You can fill the gap. You can fill the gap.
Sir, how far we are away from Israel's irrigation system, sir? Are we going the correct track? When will India achieve such a system?
No, the thing is, Israel, the stringent rules and regulation plus the lands are very huge. For example, if you talk about the landowners, the landowners generally will be a landlord means they will have 500 acres, 1000 acres. So a single machine will irrigate for 100 acres. But in our condition, within 1 acre, we have 4 bifurcations. So farmers are having 1 acre, half acre, 10 acres. So having common irrigation is very difficult. So machine, if you want to use a machine, is the most economical when you have a larger area. Because individual small area, if you invest same sensors and things like that, which is a costly affair, and the yield or the profit what you get, yes, which is not. So that is the biggest challenge in Indian condition. The probably if you see that when the corporate farmings are coming into picture, in a village, they'll take all the lands like a lease. For example, a village has 100 farmers. They will take 100 farmers' land. They will convert it into single land. They will do whatever they want. They will pay the rent for individual farmers. In those cases, it is possible. So that is not far away, and we are marching towards that actually.
So in India, which state has the best irrigation system, sir? Actually, we have participants across all the states. And
Punjab has, and even Euro district has a lot of IoT based sensor, but this is a little bit costly, yes, in the sense. But monitoring is very easy, but you can reduce labor cost, wastage can be minimized, but initial cost is more. But after that, monitoring and things are very easy actually, right? But widely, there highly litigated states are widely standing first in utilizing this or adopting these kind of technology actually. Like E-roads are performing better actually. E-road, Karur, that belts are performing better actually.
okay.
Anything else?
Participants,
Though it is slight away, but it can be applied to any field: structures, construction management, road, transport, ECE. You name the area, and whatever method we have discussed, it can be applied or it can be. Only thing is converting the actual process into your domain process is the real intelligence is required. That's all. Okay.
Thank you so much, Professor, for the very meaningful and meaningful session that you have covered all the basics related to the emerging technology, and you have given the theoretical concepts linked with all the practical applications also. And on behalf of SRM College for Engineering and Technology, I extend our sincere thanks and deep appreciation to you, sir, for accepting to be our resource person and delivering at a very short notice. And the session was really highly informative and valuable to the participants. And we are grateful for the time and effort and the expertise that you have shared with us, which have significantly contributed to the success of this FDP. Thank you, sir. Thank you so much, sir.
Thank you so much. Thank you all.
Thank you, sir.
Thank you, sir. Thank you. The participants, we have shared the feedback link for session 5. So kindly post your feedback. So, Amudhan sir, good evening, sir.
Hello, good evening.
Sir, good evening, sir.
Good evening.
Welcome, sir.
Welcome, sir. Sir, we'll start the session, sir. If you are ready, we can start. Okay, so participants, we are getting into the session number 6, and here we have Dr. V. Amudhan, a globally experienced public transport professional with over 32 years of experience across India, Kuwait, UAE, and Spain. His career spans government, states, transport undertaking, private sectors, big floor consulting environments. He is known for turning policy into practice, data into decisions, system into services that generally works for people. He is award-winning thought leader in sustainable mobility, public transport economics, EV transition, predictive maintenance, and road safety with a deep broad level governance exposure and standard and strong hands-on experience. His current role is he's an independent director in Metropolitan Transport Corporation and also independent director of TNSCST Salem as well as Coimbatore and advisor for Malawa Mobility USA, editorial member in Urban Transport News and Metro Rail Today. He is also trustee for R Safe Trust, Road Safety NGO. To tell about his career highlights, he has 18 years of experience in government public transport undertaking India, Kuwait, as well as UAE, and 14 years in private transport consulting roles and consulting exposure in 13 countries. And he also acted as a jury and mentor for Transport for All Challenge held by Government of India. To tell about his core experience, public transport governance, STU reform, e-buses, charging infrastructure, alternative fuels like CNG, hydrogen and green mobility, predictive and smart maintenance like IoT and IOM, transport economics and financial sustainability, and it goes on, the list goes on. And his academic and professional credentials are, he's a mechanical engineer from Bharatdasan University and MS from BITS Pilani in quality management and PhD in management in Young Scientist University, USA. His awards, few of his awards and recognitions are, he is awarded as Urban Infra Sustainability Public Transport Promoter of the year 2024, Global Transport Researcher of the year 2020, and Gold Medal Transport Economics and Management, Indian Institute of Railway Transport, New Delhi. So, on behalf of the organizing committee of ATAL FDP, as well as Department of Civil Engineering, as well as SRM Madurai College, I am really grateful to welcome Dr. V. Amudhan to deliver this lecture on title IoT driven solutions for disaster resilient urban mobility and smart infrastructure. Sir, we welcome you, sir. And thank you for accepting our response. So the session is to you, sir. Over to you. Sir, you are on mute, sir. Sir, is it audible, sir?
தெரியுது. உங்களுக்கு ஸ்கிரீன் தெரியுதான்னு கேட்கு.
No, sir, your screen தெரியுது, sir. No, PPT open ஆகல, but screen தெரியுது.
ரொம்ப ஸ்லோவா இருக்கு.
சார் இந்த ஸ்க்ரீன் இஸ் விசிபிள். நீங்க பிபிடி மட்டும் ஓப்பன் பண்ணா தெரியும் சார்.
பிபிடி ஓப்பன்ல தான் இருக்குது.
ஓப்பன்ல
ப்ளீஸ் மூவ் திஸ் விண்டோ அவே ஃப்ரம் தி அப்ளிகேஷன்.
நீங்க சார் சார் ஸ்க்ரீன் ஷேரிங்ல வந்து சார் உங்களோட பிபிடியை செலக்ட் பண்ணீங்கன்னா பிபிடி மட்டும் விசிபிள் ஆகும்.
வந்துருச்சு. ஸோ தெரியுதா?
நோ நோ சார். Sir, you can enable the screen share once again.
ஸ்க்ரீன் ஷேர் மறுபடியும் ப்ரெஸ் பண்ணிட்டு அந்த டேப் மட்டும் பிபிடி டேப் மட்டும் கிளிக் பண்ணி பாருங்க சார்.
பண்றேன். எனக்கு ஓப்பன் ஆயிருக்கு. உங்களுக்கு தெரியுதா?
இல்லைங்க சார், உங்களோட அந்த டெஸ்க்டாப் ஃபைல்ஸ் இருக்கும் இல்லைங்களா, அதுதான் விசிபிளா இருக்கு.
ஃபைல் ஓப்பன் ஆகுது. ஷேர்னு கொடுக்கணும்.
சார் சார் இந்த ஜூம் காலில் சார் இந்த ஷேர் லிங்க் ஷேர் இருக்கு இல்லையா சார், அதை இன்னொரு தடவை நீங்க பண்ணீங்கன்னா
நியூ ஷேர்னு இருக்கு இல்லையா?
சார் ஐ
நியூ ஷேர்ல தான்
கால் பண்றேன் சார்.
கால் பண்ண. யுவர் ஸ்கிரீன் ஷேரிங் வருது. இல்ல ஸ்கிரீன் ஃபுல்லா வருது. பிபிடி ஓப்பன் ஆகுது எனக்கு. பட் அந்த ஸ்கிரீன்ல வந்து டெஸ்க்டாப் ஓப்பன் ஆகுது. நியூ ஷேர்ல போயிட்டு தான் ஓப்பன். போஸ்ட் அட்டெண்டிங்ல போகணும். ஆக்சுவலா ஸ்கிரீன்ல போகணும். நான் ரீஜாயின் பண்றேன். ரீஜாயின். சரி ரைட் ஆனால் பண்ணிட்டீங்க நீங்கள் போய் ஓப்பன் ஆகிடும். சரி நீங்கள் லைனில் இருங்க, நான் ஓகேன்னு சொல்லுங்கள். ஓகே ஸ்பீக்கர். I have some problem in my desktop, so I asked my associate to telecast. So he will, I think, Krishna Kumar.
Sir, your audio, sir. No problem, sir. You can proceed.
Okay, shall I start now?
Yes, sir. Yes, sir. You can start, sir.
Okay. So he will change the slide on behalf of me. Now you can able to see my PPT. No?
Yes, sir. It's visible, sir. Clearly visible.
Okay, thank you. Sorry for the delay.
No problem, sir.
Good morning to all the respected faculty members, researchers, and participants. Today's session focuses on a reality we are all increasingly facing. Disasters are no longer rare events, and cities are no longer resilient by default. Urban mobility systems are the first to collapse during disasters and the last to recover. This presentation will explore how Internet of Things driven solutions can transform urban transport from a vulnerable service into a disaster resilient infrastructure. This is not just a technology discussion, it's a governance, planning, and human safety discussion. Second slide. I will first set the context by explaining how disasters impact cities and transport systems. Then we will examine the role of public transport during disasters, followed by how IoT changes disasters response from reactive to predictive. We will also look at real operational insights from Tamil Nadu, policy changes, and the role of academia, and finally a short mini case to apply these ideas. Third slide. When a disaster strikes a city, the first system to feel the stress is transport. Roads flood, signals fail, depots lose power, and communication collapses. Once transport fails, everything else follows. Emergency services, hospitals, supply chains, and evacuation efforts are all affected. So when we talk about disaster resilience, we must understand that transport is not a secondary system, it's a foundational. Next slide. Fourth slide, Balamurugan. Disaster are unpredictable and global. Fourth. Disasters today are unpredictable in timing, scale, and locations. Floods, cyclones, heat waves, earthquakes, and man-made incidents are happening across continents. What is common is that urban systems are stressed beyond their design capacity. The lesson is clear: preparedness cannot be static. It must be dynamic and data-driven. What we are seeing is a shift from rare disasters to routine disruptions, and cities must now be designed to operate under continuous stress and not occasional shock. Next slide. This is a type of disasters, and disaster impact is influenced by geography, climate, population density, and land use and infrastructure conditions. But the most critical factor is information availability. Cities do not fail only because water rises, they fail because decision makers are blind during the crisis. In many disasters, information delay causes more damage than the hazard.
Sir, you're not audible, sir. Sir? Dear participants, kindly hold on. There may be some network issue with the speaker. We'll get back to him.
सूप है क्या बच्चों को करा फोन करती है सचिन
Hello.
Yes, sir. Yes, sir.
இப்ப கேக்குது இல்லையா? Okay, sir.
கேக்குது.
Shall I continue? Sorry for the network connection இங்க problem இருக்கு அதனால.
பரவாயில்லை sir. It's okay, sir. I can continue, sir.
Okay. பாலமுருகன் நான் 6th போயிடுங்களேன். With rapid urbanization and climate change, disasters are becoming more frequent and intense. Infrastructure, however, is aging. Planning processes are slow. This match creates vulnerability, especially for transport system. This gap between rising risk and slow adaptation is where most urban failures are born, particularly in systems that were never designed for climate extremes. So major disasters in India, in this map, it is available. So you can understand about this picture and all. So we can go for the next slide. So during disasters, buses are not just buses. They evacuate people, transport emergency responders, deliver supplies, and reconnect communities. Public transports become a lifeline, not a commercial service. That is why resilience planning must prioritize buses, depots, and corridors. So enables must இதுல வந்து short time, sorry, enables mass evacuation in short time. It should be there.
And emergency responders and healthcare workers also moves from one place to another, ensures access to hospitals and shelters and relief centers also. Maintains minimum city mobility during crisis, supports low income and transport dependent populations, accelerates post disaster recovery. So Balamurugan, next slide. So during disasters, buses are not just as buses. It is urban mobility changes. Flooded roads, power failures, communication breakdowns, unavailable drivers, and manual decision making creating chaos. Most transport agencies still rely on phone calls and experience based decisions. This is neither scalable nor safe during large scale disasters. In most cities, these failures happen simultaneously, not one by one, and that is why manual control rooms become overwhelmed within minutes. So the next slide, Balamurugan. Disaster resilient mobility is the ability to anticipate disruptions, maintain minimum service continuity, support evacuation, and recover rapidly. It is not about avoiding disruption. It is about absorbing shock and adapting quickly. So ability to anticipate disruptions, we have to maintain that 4 things: maintain minimum service continuity and enable safe evacuation and ensure rapid recovery and adapt routes and operations dynamically. So next slide. IoT refers to a network of connected physical devices equipped with sensors, software, and communication systems. In transport, IoT allows vehicles, infrastructure, depots, and control rooms to continuously share real-time data. This data becomes the foundation of smart and resilient mobility. So, Balamurugan, next. Reactive to predictive modes. Before technology, disaster response was reactive. IoT makes it predictive. Real-time, traditionally, disaster response has been reactive. We respond after water enters depots, after buses break down, after roads are submerged. IoT changes this by enabling prediction floods, failures, and demand before systems collapse. And Balamurugan, next slide. Where it operates, IoT operates. IoT operates across the entire transport system, vehicles, depots, roads, passengers, and control rooms. Resilience is achieved not by isolated technologies, but by integration across systems. True resilience emerges only when data flows seamlessly across departments and agencies. So these 4 things are main important, and Indian startup glowing smart roads, how it is be connected with this IoT is how is operating it and all. It's shown in the slides. Next slide. The IoT architecture, from sensor at the field level, data flows which through communication networks into platforms and dashboards. AI process this data to generate predictions which support decisions and trigger actions. This continuous feedback loop is critical during disasters because conditions change every minute. Next slide. IoT in public bus operations. So live tracking, vehicle health monitoring, fuel and battery status, driver safety, analytics, and emergency reporting all become possible through IoT. A modern bus is no longer just a vehicle, it is a moving data node. Next slide. Smart bus depots. Bus depots are high-risk assets during floods. IoT enables flood sensors, power monitoring, fuel tracking, CCTV protection, and automated shutdowns. Protecting depots means protecting the entire transport systems. Next slide. In disaster, we have to aware about route management. During disaster, static routes might be failed. IoT enables dynamic rerouting, avoidance of flood-prone corridors, and prioritization of emergency routes. This flexibility is essential for evacuation and emergency response. So next slide. Passenger information systems. Disasters create fear and misinformation. Real-time alerts reduce panic and improve compliance. Clear communication saves lives. When passengers receive timely instruction, they cooperate, and cooperation is the strongest tool for the crowd management. It is similar like to the railway. So the next slide. In the emergency coordination, how the IoT is using. So IoT enables coordination between transport agencies, police and fire service, health departments, and district administrations. Unified dashboards improve situation awareness and resource allocation. When all agencies see the same data at the same time, coordination becomes automatic rather than dependent on phone calls. Next slide. Chennai floods demonstrated how quickly urban mobility can collapse. Now, low-lying depots were submerged, routes disappeared, and services were disrupted. So yet buses played a crucial role in evacuation and recovery. This event clearly showed that the transport agencies are often the first institution on the ground. The next slide. Operational insights. MTC and TNSCST effectively acted as the first responders. However, challenges in data sharing, legacy systems, and coordination limited effectiveness. Technology helped and adapted, but institutional readiness mattered more. Technology alone cannot compensate for a weak coordination or unclear command structures. The next slide. Policy and operational changes. There are 5 challenges are there: aging infrastructure, budget constraints, silos, and data ownership and skill gaps remain major barriers. IoT adoption must be supported by policy reform and capacity building. These are not technology problems alone, and they are governance and capability problems. Next slide. The cyber security and system reliability. During disasters, networks are vulnerable. Redundant systems, secure protocols, and offline fallback mechanisms are essential. A failed network can be as dangerous as a flooded road. Resolution systems must continue operating even in degraded conditions. Next slide. Role of academia in evolving cities. There is 4 things are key thing: disaster evacuation modeling, digital twins for transport networks, and AI plus IoT research, pilot projects with STUs and smart cities. Academia plays critical role in the above 4 things. Universities are innovation engines for resilient cities. Without academic leadership, cities repeat the same mistakes instead of learning systematically. So training futures is a disaster ready for the engineers. Next slide. AI workflow. The AI workflow follows a simple logic: sense, predict, decide, act, and learn. This loop must operate continuously during disasters, updating decisions every few minutes. Every few minutes. In short, AI tells what will happen next, and IoT shows us what is happening now. Next slide. AI IoT architecture. AI converts sensor data into operation diseases. Without AI IoT data remains underutilized. So together they enable an intelligent disaster response where intelligence replaces intuition. So here the sensors and progress and predict, decide, and act and learn. So these are the 5 things we have to integrate in that IoT technical architecture. And AI converts sensor data into life-saving operational decisions. So the next slide. You should now understand how IoT supports resilient mobility, how AI improves decisions, and why integration matters. Disasters are not unavoidable events, they are scenarios we can prepare for. Identify AI and IoT uses cases for disaster resilient mobility. Design a basic AI IoT workflow for urban transport systems. So this will be for the future, for the theory to deployable solutions. That's why this I am giving to this 6 thing. So understanding how predictive models support evacuation decisions, integrate and transport system, smart city control rooms, and propose pilot projects for smart cities and STUs. Guide students towards applied research in disaster resilience and all. So these and all we have to all the participants should know about this. And the next slide. This is a mini case Chennai flood scenario in design and AI solutions. So now I invite you to think the like system in here, which sensor will you apply and what predictions, what AI production is needed, what decision must be taken, who receives alerts, how do you protect from depots and buses. So this discussion is important because disaster resilience is context specific and there is no one size fits all solutions. So we have to minimize about this. I am asking these 5 questions. So people can understand about what is the sensor will use means, weather sensors, water level sensors, CCTV cameras and all. From this, we can take this data. And AI prediction is needed means flood risk analysis and area impact forecast is there. And also decision for alerts and all the evacuation alerts and route diversions should be taken, and we have to communicate with the respective drivers and the vehicles. So action plan, deploy the pumps and secure depots, because in the depot the water will come means we have to do the action plans. So bus management, reroute the buses and move to safe zones. So we have to give the direction to the bus drivers and respective bus supervisors and all to reroute the buses and move to safe zones. Dashboard, control center and live monitoring should be there, and it can be used monitor for the EC the buses. Next slide. So in this presentation, there is the 5 things only. 5 things are the key takeaways. Public transport is the backbone of disaster response. IoT improves visibility and speed and coordination. Public policy and operations technology must work together. Academy has a key role in innovation and capacity building. Technology alone is not enough. So academy has a key role in innovation and capacity building as also it should be there. The next slide. So disaster resilience is not built during disasters, it is designed before they happen. So we have to do this system in our MTC and TNSCST and all. Now it is in the starting stage, but I have implemented in other countries like RTA Dubai and Kuwait government transport and all. So the people they were using in advanced level, but in India there is 3 things are problem. Fund problem is there, and also capacity building and knowledge things and all. It's very lesser here. So it is adaptation and implementation of this technology. It's very difficult in India, specifically in Tamil Nadu. But what I am saying, in Gujarat and Bombay, they are trying in a pilot study. So nowadays, quietly, this is improving. So I look forward to your questions and insights.
Dear participants, if you have any questions, please unmute yourself and ask the questions. Sir, what are the major setbacks that we find in implementing at the state level, like the resilient structure for the transportation? Based on the current scenario, what are the major setbacks that we have?
Setback is mainly it is a funding and other many things are there, and the people are in implementation level. They have a lot of government procedures are there, so the procedures are very difficult. Means tendering procedure and scrutiny procedure and the pilot study and all. From the pilot study, it is very difficult to go for further stage. So they will, as you know about how the government is functioning and all. The government has to go for the EOA and the expression of interest. The stage by stage, many things are there. So in government, implementation is very difficult to implement in funding and other technology providers, because we can get the sensors and other things and all. But in India, meager quantity of technology provider for the public transport is there. So that is the biggest things. So last year, in Ministry of Housing and Urban and Affairs, they were arranged for this these type of public transport advanced technologies and all. They had some programs for transport for all changes and all. So in that program, many entrepreneurs they came and they submitted the proposals and all. But all the proposals are only like in study level, not in implementation level or something like that. So the Ministry of Housing and Urban Affairs, they decided, so they go for the further next tender and in policy level.
Like in smart cities, do we have any implementations, like at least in the pilot scale level?
Pilot study in Gujarat, it is there, madam. Gujarat only, they are only conducting. But
Okay.
here, now the Tamil Nadu government is starting to think like this. And most of in Tamil Nadu, what is the problem? No, the depots are all more than 40 years old.
Okay.
So the infrastructure things and all, it's very old, and even building also, it's very weak and rusted level and all. So that's why what they are thinking, they are removing all the depots and they are making renewal of depots, and they are going to for e-bus and other next step. So e-bus implementation and all. So initially they were implemented in 5 depots as a e-bus depot. From that only the World Bank and JICA, that Japan Investment Agency, they were funding now such a huge amount to the infrastructure development. So, but in Gujarat, they were finished the pilot study and they are going to float the tender for the next for the implementation.
Okay, sir.
In Japan and Korea and all, there are many bus stops are there. Bus stops means they were preventing of the COVID, and many applications are there. And in Hong Kong, the public transport firms, they were providing the Heato shirt with full of sensors. It will give the health condition of drivers. So the health sudden heart attack or sudden health issues, if any found from the drivers, it will be and the management can be replaced with other drivers, or they can give the leave and they can take care of the health of the drivers. So many advanced things were happening in around the world, but in India it's very difficult. Slowly it is going. Now only they are thinking about very how to go with IoT technology and predictive analytics and all. Predictive analytics in operation is entirely different, and maintenance is entirely different. In the vehicle, so many sensors are there, because in BS4 and 5 and BS3 and 4 and all, the limitable sensor is there. But in BS6, the very full, as per the BS6 norms, it is fully built with the sensors. So so we can take the error codes and failures, all the things and all from the BS6. Last 2, 3, 4 years before and all, this is not possible. Now we can take the error codes without going and touch the vehicle or open the vehicle. We can see what is the error is happening. So now the technology is slowly emerging and developing in the India, but slowly only. It's not as fast like that.
Good, sir. Thank you so much, sir, for giving us a very
Sorry for the net problem. It is there. So
It's
that's
okay,
why I
sir.
couldn't
It happens
continue.
It happens at times, sir. No issues.
Yes, madam. Thank you, madam, and thank you, Krishna Kumar and Balamurugan. Thank you, sir.
Thank you, sir. Thank you so much, sir. Thank you for sharing your time, sir. Thank you. Thanks a lot.
Okay. Thank you.
Okay, participants, thank you for listening to the session. I have shared the participant feedback link. Please post it. And the recorded videos has been uploaded in the YouTube link, and the YouTube link is shared in the WhatsApp group. Also, I'll mail the link. We are yet to update the attendance in ATAL portal. It will be updated soon. Gaurivan, thank you.
Yes, sir.
I'll handle them. I'll wait for a few more minutes and I'll leave.
Okay, fine, sir. Carry on.
Thank you.
I think we can close the recording.
Yeah.